A few years ago, my dad bought a Cat 906 loader for our farm, and it has turned into a way bigger project than what we'd first thought. We knew it needed work. We knew it needed work on the bucket. There was all sorts of sloppy linkage up front, but the rest of the machine had pretty low hours and seemed to be in pretty decent shape. We got busy with other projects, and it just sat in the shop for a little while, and just sitting, it developed a pretty big oil leak, and it turned out that one of the hydraulic hoses underneath had rusted through. So with a little more further investigation, we realized that pretty much every hydraulic hose underneath the machine was rusted to the point of almost breaking. While we were messing around with the hydraulic lines, we also noticed that the radiator appeared to be leaking, and the first step for replacing the radiator was to take off the cab. So off the cab came, and it was a lot easier getting to all the other hydraulic lines once the cab was off, so we probably should have done that sooner. We had to fight with pretty much every piece of this loader to get it apart, and the center pivot was no exception. We spent a long time trying to get this thing apart. This video is really sped up, and it still looks like we're not getting much done. So this was the first day of pounding and beating. We've got a jack underneath. We're hammering down. We're trying to break things free, and it's just not moving. Eventually, we decided we needed a bigger jack underneath, so we welded on this whole frame underneath the loader so we'd have a solid place to put the jack, and we borrowed a 50-ton jack from our neighbor because we didn't have one big enough, and got that bad boy in there. And we eventually got it free. We actually ended up bending the loader frame a little bit, but it took this jack and sledgehammering and a lot of time to finally get this pin out. But we got it out. It's a little hard to see in this picture, but where the lower bearing went in the loader frame is all sort of egged out and hammered up a little bit, and the bearing was just completely destroyed. So we decided that we wanted to get that machined out and nicely fixed. We had hired somebody to do the loader arms for us, and they did a great job, but they charged us quite a bit, like $1,500 to do the two arms, and we decided that we didn't really want to pay somebody to do this when we figured I could probably do this part myself. The first step was to build up the bore with weld. It actually came out fairly well. I mean, it looks a little lumpy in the picture, and it was, but, I'm doing it by hand inside a hollow circle, so, not the neatest, but it ended up working out just fine. So here's the sketchy setup I have to mill the center pivot for our mini loader. I've got a variable voltage transformer, open with wires sticking out of it, going up here to a mini milling machine bolted or clamped down to the machine itself. So I'm going to see if I can get it a little closer. So I have got this welded up, but I want to face it and get rid of this upper weld so that it's all nice and smooth, so I can put the retaining ring on, and then I can center off the retaining ring, and then I can bore this. It's going to be a bit of a tedious task. So, place your bets. Is it going to work? Now, I know what you're thinking. That cutter is way too big for that milling machine, and it's going to spin way too fast and cause all sorts of problems. I know I wanted to use my smaller cutter, but because of the way the mill's set up, I couldn't get enough travel to use a more reasonable sized cutter. So I don't have very high hopes for this at this point, but I just wanted to see if I could get that faced off with something besides just a handheld grinder. Spoiler alert, I ended up using the handheld grinder for the facing operation. So here's my setup for boring out this pivot on our mini loader. I've got a little got got a central machinery milling machine that I got for free from a neighbor who was moving. It's a little bit janky. It has, the table flexes, and the table's not meant to work in this direction pulling down, so I've got it clamped here with these F clamps, and then I've also got it jacked up from the bottom to hold it up to the loader. And I've got my homemade high-speed steel bit here that's a stub of an old end mill. I have a real boring bar, but it's the wrong direction. It cuts the wrong direction for this operation. So I am about to try to see if this works. I'm going to bring you in a little closer and we'll find out together. That didn't.
See the tickle?
It mangled my high-speed steel cutter. I just mauled it. I wouldn't think that would be that hard, but yeah, that's definitely did not cut. I wonder if I got it from an end mill. I wonder if the shank is softer. Of course, it was a Chinesium end mill. So, on to plan something or other. So, that didn't work. Surprised the weld is that hard. I was maybe going a little bit fast, but I don't want to go slower because the way I have to vary the speed is a variable, it's varying the voltage down, and so that means that I get a lot less power at the lower speed.
And can you also overheat it? The lower voltage? Or burn something out?
Maybe. This is my experiment. I wanted to try cutting with carbide because it just mauled that high-speed steel. So got my lathe turning tool and this adapter to let me put a 3/8 square into a 5/8 round hole. So the set screw will go like this. Set screw will push there and hold it all into my boring head. I think I see shavings this time, which is good. Yeah, I want to fix that because it does shake a lot more. But if you look at this flexible coupling, it really is not lined up with the bottom one.
Yeah.
So if I can get that more lined up, okay.
What do you have to do to line it up?
I don't know. So, so since I stalled it, it's shaking a lot more, and I think it's because this flexible coupling isn't lined up. Top and bottom has to work really hard. It'd be hard to see in the camera, but these are really far off. So I think perhaps one of the other bolts loosened and it slipped a little bit or something. I don't know. I know it's probably not going to be a surprise to the people watching, but this is not the most reliable setup. So the newest problem is the input isn't attached to the output. So here I'm spinning this. This is not spinning. There's a missing set screw down there, which I cannot get to because all this stuff is in the way. So I'm going to take it apart and see if I can put the set screw back in and see if it then works. I could just put a drill right on this one, and that would work. So anyways, I've got options. So this wonderful setup is, so unsurprisingly, I had some difficulties with this setup. First, the set screw that holds this aluminum piece on came out, that little guy right there. And to get that one back in, I had to take the rest of the drive system off to make it, to be able to access it. Now, the interesting thing is, well, and I also noticed that there's a chunky spot in low speed. So I'm like, well, that's not good. So, and also the shaft output of the electric motor that was on top is a little bit wobbly. So I figured that I'd try to power it with just a drill. And surprisingly, that works. Well, not too surprisingly, but it cut. I got one cut out of it doing this, but believe it or not, this Ryobi drill has too much torque for the plastic gears inside there. So first it was just the low speed that had some chunky spots, but now the high speed also has some chunky spots in it. So now this one also has some pretty good chunky spots in it. So those plastic gears are just done for. So I'm not giving up. Came up with plan, I can't remember what plan it is. It's plan, I don't know, several different plans down the road. So I want to drive this directly from here because I don't want to deal with the plastic gears. I was going to give this away to a friend of mine, but I wanted one last hurrah with it before I gave it away. And he can deal with fixing those plastic gears if he really wants to. Or he can tell me now after I've abused this thing that he doesn't want it. But anyways, I want to drive it from here. And at first I was going to drive it from this part, but from reading online how to replace the gears, this is a left-handed thread nut, so that's just going to unthread. So instead, I'm going to clamp down on this lower piece with this custom, special, homemade socket. Let's see, I need to loosen up the set screws. So now that will go on there. And yes, I'm just driving with set screws, but in some ways, work with me here, that's a good thing. Because if it does bind up, that's sort of a clutch point where it'll slip and it won't actually break the rest of my setup. That's an idea. I could, put in little flats in here if I wanted it to be a little bit more, secure. I have to tap that straight because that's a little wobbly where it is now. But I know what you're thinking, well now how are you going to turn that? Well, you just wait. If you're a fan of the ridiculousness of this setup. We've got wooden blocking here, homemade screw jack with a metal plate pushing the mill up against the loader frame to hold it solid. We've got 1, 2, 3 blocks and clamps holding it to the mill. We've got these F clamps also holding, probably not doing that much, but you got them, they're adding just a little bit. We've got Central Machining Taiwan, or made in China milling machine special. Bridgeport boring head with high-speed steel cutter in it. The carbide one chipped, and I think the interrupted cut might do better with high-speed steel. And got a custom holder to allow me to put a 5/16 square in a 5/8 round hole, so I can put a boring, just a regular piece of high-speed steel in there. Then we've got the drive removed from this milling machine. It's in neutral, but we've got a custom-made driver to drive the spindle directly. We've got a 7/8 socket, a universal joint, a gigantic magnetic drill, Bucks mag drill setup. This is a Milwaukee hole shooter something or other. And then we've got a steel plate welded to the machine holding everything in place. Well, I wasn't actually cutting that time. That was at the same depth setting or same diameter setting as I had before, because now I need to set my depth, so I stop at the same spot every time. So let's see. I'm going to fiddle with that, and then I'll give it another pass. So it's a little hard to get the camera in here so you can see, but I've made a couple of passes. I switch back to the carbide. I think with the speed that I have to run this, I do have a variable speed thing, but I want it cuts down on torque and whatever else. So carbide seems like it's working a little bit better. Let's see, there's my surface finish there. Let's see. Yeah, and I have to leave a shoulder down here, so I need to stop at the right point. I should probably scoot this up just a little bit, but so yeah, it seems to be working. The interrupted cut is hard, but it's getting less and less interrupted as I go, so that should be good. The surface finish is, well, unsurprisingly not great, but it doesn't need to be perfect. Well, it worked. So this wonderful setup, got the bearing kind of started in the hole. It's not going in square right now, but it started in, and it seemed like it's going to be a great press fit. Can't pound it back up out. Well, we need to finish grinding down this up here to get it nice and smooth, but we can't do that with the bearing in, but we wanted to check it first. So anyways, it's not quite done completely, but done with the machine work anyways. Yeah, so this process started with me just thinking I could maybe just use the mini mill, but it turned out the gearbox in the mini mill really wasn't up to the task. So then I needed to find a different way of powering it. And my dad suggested using my wonderful mag drill there. So that mag drill directly turns the spindle, goes down, turns the milling machine, gets fed by hand. Down underneath the milling machine is held up by a jack and clamped in. There was still some flex. There was still some flex in and out because there's a lot of distance between the cutter and there. There's lots of places for it to flex. So we welded in this little support, and that really firmed things up. Before, you could feel the mill, wobbling in and out as we were boring, and that's no good. Couldn't feel it go side to side, but probably was at least a little bit. But now with this support, it's nice and secure, and got a pretty decent cut. So now it's time to take this all apart and get the new bearing installed. This is about what the finish ended up looking like. It actually was a little bit better than this because this was done before I added in that upper support. So, not fantastic, but it's certainly a heck of a lot better than what it was before.